Conference will now be recorded.
Switch off the slide. Center center. Yes. Good morning, everyone. Screen and audio both are fine or not? Please confirm. Online students. Screen and audio both are fine or not? Please confirm.
Yes.
Okay. Thank you. So, as you know that this is physical design demo session, right? Everyone are recent pass out or recent pass out only, like 22, 21. Okay. You. Online, everyone are recent pass out or 2020, 21 or before also?
No.
Passed out.
Okay. Can you mention in chat box so that I can understand? Recently means like 1 to 2 years. Fine. Most of you are recent only. Yes. Okay. So this is the demo session for understanding what is the core structure which we are going to follow here on physical design. Just a second. Yeah. Can you please come to third floor TRT? I think there is some projector issue here in this one. Online students will start in 5 minutes. There is some technical projector issue. Yeah. Oh, yeah. There are It is visible. Okay. So we'll resume what we have started. So before starting, this is a demo session on physical design. So what we are going to see in this demo session, like what is the course structure, what we are going to follow, what are the syllabus, and what will be the duration, by what time we'll be completing this course, what are the opportunities, how recruitment will happen, okay, how placement will happen, what is the procedure for mock test, interviews, and other things, like what are all companies. So every questions will be answered based on what physical design as a profession. So what are your opportunities, everything will be covered here in this demo session, so that you can get a overview on physical design, and it will help you to decide whether I should go ahead or not with this subject. Okay. So first of all, before starting physical design, I would like to ask one question. So can you tell me what is VLSI? Hmm. Anyone? What is VLSI? Online students, what do you mean by VLSI? What does this mean? That is the full form. But what does that mean? Large number of transistor in a chip. So when we are saying chip, what does that chip means? N number of transistor in. So yes, that is correct. So what does chip means? Integration of large number of transistor on chip, you are saying. Chip means what? Anyone? Physical design is part of VLSI. Okay, it is a subset of VLSI. VLSI is like a ocean. Physical design is like a one sea. That's all. So we need to understand first what is VLSI actually. what is going to happen inside the VLSI. Yes, it is nothing but the silicon wafer, right, or silicon material. On silicon material, we are going to fabricate chips. That is called as chips. Chips means nothing but small pieces of silicon parts, right? So if you have one complete wafer, what does wafer means? So you eat a potato chips, right? So we call it wafer also sometimes. So if you take a potato and cut it into slices, right? So that one slice is nothing but called as wafer. So on that one wafer, you can fabricate multiple number of chips, right? Or multiple pieces. Same design can be fabricated multiple number of times on same wafer. Right? Later on, it is cut into pieces and then it is packaged. So this is the end product what we are seeing, right? So whatever you see in market. Also, you know that VLSI is very large, right? Nowadays it is booming also. Earlier we don't know much about VLSI. Why? Because it's very difficult to realize the circuits. We don't have much tools to realize circuit or to design circuit in that scale. When I say in that scale means what? When I say in that scale, what does this mean? In very small, right? In very small area. So can anyone tell me what is the size of chip? Or you are saying number of transistors, right? Many number of transistors are fabricated on silicon chip, right? This is what you are saying. It is nothing but fabrication of number of transistor means what? The transistors, number of transistors means what? So it is having some network, some circuit, right, or some design. We can say some design. So design made up of number of transistor. So when we say transistor, can you tell me what is the size of transistor here? What is the size of transistor? Size of transistor, right? So you might have seen in your college, in labs, you might have seen some transistors or not. What transistor you have seen in your college, in your labs, practicals? BJT transistor, right? You have seen bipolar junction transistor or not? Right? Have you seen MOSFET also? MOSFET also you have seen or not?
Yeah, yeah, sir.
So what is the size of that MOSFET which you have seen in college? What is the size of? So whatever transistor you have seen in college, probably it is bigger in size, right? But nowadays we are having very small size, very small size transistors. Yes, it is in nanometer. We will say that it is in nanometer nowadays. So the latest nowadays, the market available chips, right? Can anyone tell me market the chip which is available to market? What is that size? It is 3 nanometer, right? If you see Samsung, yes, 2 nanometers still going on, but 3 nanometer is readily available in market. We'll see a lot of phones nowadays using 3 nanometer chips, right? Samsung, uh, like Qualcomm, and many other companies also developing these chips. So if you see the large base of application, in each and everything chips are used, right? You name any electronic device nowadays, so it consists of a VLSI chip. You name anything, like you wear a smartwatches, you wear a earbuds, or what we call wireless earbuds. So those are also having chips. You say washing machine, you say air condition, you say TV, you say smart homes, or nowadays switching system is also having VLSI chips. Even cars are having VLSI chips, right or wrong? So you know there is one system called as ADAS system in car, which helps us car to drive in autopilot mode. You know or not? So that is only possible because of chips. Not only these commercial products, also in products like what we say military based, medical applications, space programs, everywhere VLSI chips are used nowadays. Why? Because the size is very small, the complex to complex circuits can be accommodated and integrated in very small area. That is the major advantage of this chip. Now thing is whether we can design this chip, right, by our like pen and paper. Can we design this chip by pen and paper, by pen and paper method? Like you might have studied network theory in your college, right? So there you might have drawn some circuit, and then you have connected in breadboard, using breadboard or some PCB layout. You have done or not these labs and practicals, maybe as a part of project or maybe in your labs, right? So you have seen those circuit by your eye and it is visible, right? So similarly, can we design these chips on paper using pen? Yes or no? Of course not. Why? Because size is very small in nanometer. Earlier days, like 5 to 10 years back, so we have 180 nanometer, right? More than 180 nanometer also we have, right? Zero point 0.1 microns, zero point 0.2 microns. Nowadays we are having 180 nanometer. We are having miss earlier days 90 nanometer. Now the commercial products are in 3 nanometer, 5 nanometer, 7 nanometer, 10 nanometer, 14 nanometer, 28 nanometer, and so on. Right? So these all are what? Sizes of what? Sizes of sizes of transistor. Right? When I say size of transistor means what? What this thing is signifying, what this number is signifying. If I say 14 or 28 nanometer, what this number is signifying? It is telling us about channel length. Channel length of what? Transistor. Which transistor? So there are many devices, right? So you will say that like there are BJT, which is current driven device, right? Current driven device is nothing but called as bipolar junction transistors. Now we have FETs also. What are FETs? Right? So there are many types of FETs. So there are JFETs, there are MOSFETs. Nowadays we are having FinFETs, we are having GAFETs, right? So there are nowadays many devices available. So it has seen. So if you will see that, so MOSFETs are majorly used in product as a used in product designing or chip designing, right? So you might know the structure of MOSFET or not. What is the structure of MOSFET, right? You will see there are diffusion layers, in diffusion. This is substrate. So what is this type of transistor called as? What is this transistor? This is, yes, NMOS, right? It is a NMOS transistor. Okay. So this is what? This is a cross section of device. It is like you take a cake and cut it into half. And if you see the side half, how it will look like? It will look rectangular or not, right? Some layers. Okay, but see, this is also a cross section of devices. Now I will extend these lines. Now it looks like a 3D device of MOSFET or not. Now what are these? What are these things, right? These materials. This complete material is what? Silicon chip, right? Sorry, silicon material. Now these silicon material, it is a pure silicon or not? Substrate is a pure silicon or not? So how we can get the advantage from pure silicon? So what we will do? We'll do doping to this pure silicon, and we'll get different types of material. So we'll get N type material, we'll get P type material. One is what? Electron dominated material. One is hole dominated material, right? Similarly, we have doped here and got what? N type material, right? Now what is this layer? This particular layer? It is called as silicon dioxide or not? What is this layer? This is called as polysilicon, right? It is a polysilicon. Gate is always connected to polysilicon. Now you have other terminals also. Yes, source and drain. Which one is source and which one is drain? How you can tell that left side is source and right side is drain? So can I write drain here and source here? We can write, right? Then how we can tell left or right? So it is based on voltage biasing. How we are connecting these two voltage terminal, it decides which one is source and which one is drain. So if it is NMOS, the source side will be always connected to lower potential, right? So let's say if I'm marking this as drain, so this should be connected to higher potential. So what I will do, I will connect a voltage source here, right? So this is higher potential and this lower potential terminal I'll connect to VS, right? So this becomes what? VDS, right? Now I want one more voltage, right? One more voltage. So one more voltage for having channel formation. How to get a channel here? So I need to give some additional supply to gate also so that it can be charged up. So this gate terminal also I'll give one voltage, right? Some voltage, higher potential I'll connect to some voltage and lower I'll connect to source, right? So this becomes what? VGS, right? Now to have a channel formation, right? How conduction will happen? To have a channel formation, we should, when channel will be formed, when there will be channel. Yes, please mute. Yes, Gangotri, please mute. Gangotri Praveen. Okay. Now when how this channel will be formed, when we'll get this channel? When you are giving some voltage here attached. So this will be positively charged. Now this will attract what? Negative charge, right? The channel will be formation. Whether conduction starts, whether conduction starts, no, right? Conduction still not started, right? It is not conducting. Channel has been formed. Channel formation is done, but conduction still now pending. So when conduction will happen? When you start giving VDS also. When we start giving VDS, now what will happen? It will be having some voltage or not. Now these electrons will be attracted here or not towards positive charge. These negative charges will be attracted or not. In this way, what will happen? Your current, the electrons will start moving from, see here also we have negative charge. It will start moving from source to drain, right? Like this. Sorry. We'll move like this, right? Circuit is completed. Now, so if electrons are moving in this direction, now current direction is from drain to source or not. So this current is called as drain current, right? This current is nothing but called as drain current. Now, how you can define this drain current, right? So ID is nothing but mu n C of W by L VGS minus VTH whole square by 2. This ID is nothing but saturation current, right? When we will get saturation current? When your VDS is max, or we can say VDS when it becomes equals to VGS minus VTH, you will get saturation. So what will be your plot? Linearly it starts increasing what? Current with respect to VDS, and then after some time it becomes constant. This point is called as what? Pinch off point, right? When this will happen? When VDS is equal to VGS minus VTH. Understood? So this is the main region where we are going to, where lot of applications will be extracted, means we will develop lot of application out of this. So this is about device, just I'm giving one example here. So this all thing happen, this device formation happens on one silicon piece, right? So like that, this is one transistor. So in one chip, in one wafer, right, you will have multiple number of chips. Each chip will have number of transistors, number of transistor devices, these devices, right? Now these devices can be connected or not. Now this is what a MOSFET or not, PMOS. I'll use one PMOS, and then okay. So yes, audio is fine or not, or lagging everyone? So this is NMOS. You can check from your side then. Harish, you can check from your side. Maybe it is network issue. So this is what, if you use PMOS and if you use NMOS and you connect it, right, like this. This is VDD, this is V in, this is V out. Now I am using two MOSFETs. One is PMOS, one is NMOS. Now using two MOSFET, I can get what? CMOS inverter, right? Right. It is CMOS inverter. Now, if I increase number of transistor to 4 transistors, right? Let's say I will draw something like this. Now, what is this? So these are NMOS. These are two NMOS. This is two PMOS, A bar, B bar, A, B, right? This is ground, this is output. Now what is this? This is CMOS inverter logic. If I increase count of transistor, now what I am getting? What I am getting? What is this logic called as? It is a NAND logic, right? This logic is called as NAND logic, right? If same number of transistor, if I connect in this fashion, if I connect in this fashion, now what is this logic called as? This is NAND. This is nothing but, yes, this is NOR, right? So we can understand from here that once we know about the device, now that device can be used multiple number of times, and with the proper appropriate connection, we can realize some logic, right? So like there are many primitive logics, as you know. What are those? Those are NOR or XOR logics. Not only these, you can also half adder, n number of designs are there. Even you can design what? Yes. Now is it is breaking, or is it clear? combinational cells. You can also taking, or is it fine? It is fine.
Hello, sir. Your voice is tracking, sir. Cannot properly hear your voice.
Just wait. Now it is fine. Is it audible?
Yeah, sir.
So now you can also design lot of flip-flops also. Now what? You have many logics, combinational cells, all combinational cells, sequential cells. Now using these combinational cells, sequential cells, you can design many designs like memory designs, right? ALU design, display, audio video, right? DSP processor, Bluetooth module, modem, right? CPU, processor, many designs can be designed using what? These logics. Now these are like what? Some system, CPU system, ALU system, memory system, right? These are what? Some system is nothing but a collection of networks, right? You take these system and place it inside one area, some area we are telling here, let's say some area A1. Under A1 area I am placing all these system, right? Something like this. I'm placing all these system. These are what? Some system. So system A, B, C, D, E. Now these are all system or not, right? There are lot of networks inside using some logics. Now, this particular chip or this particular design of chip is called as system on chip, right? So this is nothing but called as SoC design or system on chip. This each chip can be interconnected. Okay, this each chip, I mean this each system can be interconnected. Lot of pins will be there for each system, right? So that it can have connections. Externally also you will have lot of pins. So this is nothing but called as system on chip. You understanding how we are going from basic transistor? Now each system will have multiple number of modules or not? Modules and sub modules, blocks, right? Each modules will have lot of sub modules, right? Lot of each block will have lot of modules plus sub modules. Now each modules can be designed using what number of transistor? Many transistor, maybe hundreds of transistor or maybe thousands of transistor, right? But if you calculate total number of transistor for each one, means for this SoC, what will be the number of transistor here? In billions, right? It will be in billions based upon which tech we are using. Let's say we are using deep submicron region tech. Deep submicron means any technology node which is less than 90 nanometer is nothing but called as deep submicron region. So let's say I'm talking about deep submicron region. You can have billions of transistor in this small area. Now what is this small area? How much is this small area for SoC? So it is same as your fingernail size, right? What is your size of fingernail? Thumbnail? So that much size is there for SoC chips. Is it clear? Now, if I ask you what is the size of transistor here, right? So you will say that it is 28 nanometer, 90 nanometer, 45 nanometer, 14 or 10 something you will tell in nanometer, right? Can you tell me what is the size of coronavirus? What is the size of coronavirus, anyone? You know or not coronavirus? You have seen? Where you are seeing? It cannot be seen, right? From naked eye. We need microscope to see that coronavirus. So can you tell me what is the size? Anyone from online or offline? No idea? At least guess. You can make a guess. Hmm. Make a guess. Microns. Okay. 20 nanometer. Okay. Nano. Nano means how much nanometer? Guess. Yes. Offline. Any guesses? Any guesses you can make, right? It is a guess. No marks will be given to your guess. Whatever, if something is coming in your mind or not, some number, definitely some number is coming, right? You can speak out. Hmm. Guess? No guess? 10 to 20 nanometer. Here. So you should find out, right? It is 150 to 200 nanometer actually. Okay. Is not 150 also, 170 to 200 nanometer. So coronavirus size is 150 to 200 nanometer. Why I am giving range? Because there are a lot of variants nowadays. So based upon that, I am giving this range. So the first, the COVID, the coronavirus which came, the size was 200 nanometer. Okay. So you can just imagine on what scale we are designing compared to this size, right? It is even smaller than coronavirus. So we cannot use pen and paper to design these chips. For that purpose only what we require a some support or some help. Now that support and help is called as EDA tool, right? What is EDA tool? It is electronic design automation tool. So it is nothing but a kind of CAD tool. We cannot say, yes, it is a CAD tool only. So it is an electronic design automation tool means what? It helps us to design hardware, hardware circuits, or you can say hardware design, right? Because we cannot see and we cannot draw those circuits by using pen and paper or breadboard or PCB also. Even PCB is also what, very big in size. We cannot use PCBs. So we need some tool to design in nanoscale. That is why these all topics, whatever we are going to discuss, will come under nanotechnology. So when we talk about nanotechnology in nanoscale, so lot of things will be changing, right? It's very difficult what you cannot see, very difficult to design what you cannot see. Lot of different parameters will also change, right? You can see there are a lot of transmission line. You might have studied that in EMF, right? You might have seen while traveling from train also. There are very huge, tall transmission lines or not. Have you seen ever from outside window? You might have seen, right? Now, why they are constructing at that height? Transmission line are constructed at that height. Why? Why that much of height? There are no buildings. There are no people living in. It's completely outskirt fields. Still, why they are constructing at that height? Because these are, you might have studied also in EMF and these subjects, because these are what, very high tension wires. High tension means very high voltages are there, right? And due to which, if it comes near to what, ground level or human contact or animal contact, people will die easily, because the interference is very high here around these wires. So these wires are so powerful that you don't have to touch those wire, right? You just go near to that wire, finish. So that much powerful. That is why they create these high tension wire at this height, because no tree contact, no human contact should be there. That is the reason. So this is about very big gauges of wire. Think about nanoscale, where you have lot of billions of transistor. Now these billions of transistor needs to be connected or not. For this reason, you will require lot of interconnect wire, which will be very close to each other. There will be like hundreds and thousands of wires will be connect, means we are flowing like this in this fashion. Very close means what? Lot of interference will be there or not. If there is a kind of heating issue, right? If you take that chip into some high temperature like desert area, or you bring it in some high temperature region, so materials can get distorted, right? It can get melt, it can get defect, it can melt and it can stick with other wire near to this, right? Then it can cause short. Your design will be failed or not. That is why it's very complex. Nanotechnology designs are very, very complex. If you miss any one parameter, your design will lead to failure. That much crucial and critical is this. And I'm just giving one example. There are n number of parameters. Once we start course, we'll understand all critical things each one by one. Okay. So we will see the course structures and what all topics. This is overview about VLSI, what is happening, right? So in that VLSI, we have lot of different stages. So we have front end and back end stages. That also I will cover here. So here we are going to cover course structure and the topics which we are going to cover. So how placement and these things will happen. So we'll also see the complete ASIC design flow also, and we will see some advanced physical design concept, right? So let us start from course structure, what we are going to follow. Okay. So total duration will be 6 months. So first 2.5 months will be for PD basics, right? And second half, that is 3 to 4 months, will be allotted for PD advanced session, which is purely about physical design. There will be no other subject. Okay. Here in this PD advance, we will also carry one real-time project also, right? One 28 nanometer or 14 nanometer project available here in this institute. Any one of those project we will carry forward. We'll give you assignments also based on project, and you will be also doing same project parallel with the mentor itself. Okay. Now, what are the topics which will be covered in PD basics? So the topics which are going to covered are digital basics. You might have already studied in semesters, right? GVIM basics. What is GVIM? It is a text editor, like a notepad. You might have used notepad in computers, right? It is nothing but a notepad. It is a text editor which can be used using some commands. So it is some advanced text editor, not normal one. Then we will also learn about some basic Unix and Linux command. Okay. Then tickle basics. What is tickle? So tickle, or it is also called as tool command language, right? It is a scripting language which is used to, it is kind of programming language which will help us to write routine task. Okay. So CMOS basics. CMOS, you might know, just now I have explained few topics related to CMOS only, right? CMOS is nothing but complementary metal oxide. So it has by default inversion behavior. These devices has by default inversion behavior. Physical design basics. So we'll see all the terminologies related topics to physical design. Before starting advanced session, we will give you 1 week to 10 days of time for PD basics only. PD basics means not in depth, just to make you familiar with the PD terminology, because you're new to this VLSI, new to this physical design. So there are n number of new terminologies will be there, which will take time for you to absorb. That is why we will give 10 days extra time or first time, so that you can get familiar with terminologies. What will be the class timing? So daily it will be 3 hours. So complete starting from Monday to Saturday and Saturday and Sunday. So from Monday to Saturday, you will have lab sessions. Saturday, you won't have lab sessions. Mostly Monday to Friday, you will have lab sessions. On Saturday, Sunday, you will have theory sessions, weekend sessions. Is it clear? So weekdays you will have lab session, and weekends, Saturday, Sunday, you will have theory session. Both mentors will be different. In lab session, you will be having trainer, mentor who is related to lab sessions. For theory session, we will be bringing some industry expert on weekend, because they are not available on weekends, sorry, weekdays, so they will be available on weekends. So that is the reason theory sessions will be on weekends. Now, of course, some people are here from working people, right? Is there anyone who is working, or everyone is pass out?
Mutahar, sir.
Okay, so there will be some people who are working also, working in some other domain, right? Maybe in IT, or maybe some networking or something else. So these people do not have that much of time on weekdays. So for these people, we have weekend batches also, for working people batches also. Mostly they will be attending online sessions. So what will happen on weekends only, on Saturday, Sunday only? Morning session will be theory session, which will be common for both the batches, means regular batch as well as working people batch. So theory is common for both. What about lab session? The lab session for working people will be on weekends only after theory session. Is it clear?
Okay, sir.
PD advanced sessions, right? So PD advanced sessions will be for 4 months. So where we will be covering EDA tools, right? Just now I have told what is the importance of EDA tool. Why we need EDA tool, you got to know, right? So what are all EDA tools? So from Synopsys, we have DC, it means design compiler used for synthesis. ICC2 is for PNR, floor plan and PNR. Fusion compiler also we have, prime time and star RC. ICV is also there, but it is not for us actually. ICV is used by custom layout people. If you choose to use learn custom layout, so you will be using ICV also. So cadence support is also there in our institute for Genus, Innovus, Tempus, and PVS. Okay. So what will be the class structure? So weekdays we will be having lab session, and weekends we will be having theory session. This is for PD advance. For PD basics, it is common for all. All weekdays, weekends we will have session. Okay, because we don't have. So we will have some regular trainer here for PD basics. So on weekends we will have theory session, as I explained, for PD advance. So it will be for 3 hours. For weekend batches, means for working batches, after that you will have lab session also. Clear about the schedule? Any question here with respect to this one? Schedule, when, what, which batch, timing, slot? Any questions here? Okay. I'll move to next slide. So how placement support and interview preparation will happen, right? How this will help you in your preparation. So ultimate goal, why you are trying to join this institute, why you want to learn this subject, these questions should be clear in your mind, right? If I ask, what is the reason you want to join this subject or this domain? Can you tell me what is your name? Yes, please tell me. Working in last year, I was working in assistant in municipal corporation. Okay. Contractual basis, so I want to switch to VLSI. Okay. But why VLSI? What is the reason? As my pass out is 2020, like they are expecting a experience. No, that. But why you choose this? There are many different domains also. What is the reason you are choosing VLSI or physical? Electronics. You are interested. You want to say that you are interested. So this thing should be very clear in your mind why you are joining this course. All other things are secondary reason. First thing is whether you are interested or not, what is happening, whether you are clear about it or not, what we are going to learn, whether you are clear about it or not, what is the end product, whether it is giving some value to society or not, whether it is clear in your mind or not. That is the important question, right? So this, after this, our job will be there to help you with each and every support you need, right? So regular tests and assignments will be given to you. after each subject, each session, each week, right? Each week or each month. So regular assessment, which will be tracked regularly. So there will be some assignment questions which will be regularly given. Okay. Mock interviews will be also given to you once you have completed the PD advanced course. So you start, there will be regular mock interviews for you so that you can get a practice in interviews. See, only knowing about the subject is not sufficient, as you know, because your end goal is what? To get some job in some good company. That is your end goal of this motive of this joining this institute or not, right? Joining this institute motive is not just getting a certificate, right? No one has this motive. So everyone's motive is to get some good better job from here, right? Okay, so for that reason you also need to be good in soft skill, communication, English. So I've seen a lot of people who are struggling with English, or not only English, even if you can talk in English, whether you are able to communicate or convey the message to the next person is not, that is nothing but called as communication, right? So you can talk in any language, but thing is whether whatever you are saying, is it easily conveyable or not, right? So important part is communication means not English, right? Communication means what you want to express. Second person is understanding it or not. That is called as communication, irrespective of language. I'm saying, irrespective of language. So why English means, because the corporate industry, right, or a lot of companies, all they have or global market, everyone is talking in English. So there is one common language so that it becomes easier to communicate with anyone, right? There should be one common language. If everyone talks in different language, then it will be difficult. So there comes, we need English. Okay. So communication, soft skill, way of talking, what should be answered, what should not be answered, everything will be covered here in mock interviews. So in mock interviews, your technical ability of giving the answer and your soft skill, what are your interests, that will also be covered. So based on these mock interviews, you will be given one dedicated feedback also, how you are performing, what are your negative points, what you missed, right? Those all things will be covered here in interview preparation, where you will also get the resume support also. Some people I have seen that they will not write in proper font. Their alignment is not there in resume, right? They are giving photographs on their resume, right? They are giving their personal details also. I have this much sister, this much brother, right? So you should not give all those details. What should be given inside the resume? What data should not be given inside the resume? Everything will be covered here in this interview guidance session, right? And what are all frequently asked interview question, so that will also be given to you so that you can get a practice of giving mock interviews. Is it clear? So this is about
Yeah, clear,
placement
sir.
support interview. Yes, it is for both. It is not for like e-learning or off learning. So this is common. These sessions are common for all e-learning as well as offline batch, right? So you don't have to worry. So common session will be there. Okay. So for weekend batch also, even for working people batch, those who are attending Saturdays, Sundays only, because their weekdays are not available. So mostly these sessions are conducted on weekends only for this purpose, so that you can have common session. So what is the placement process and how you will get recruited, how you will be getting selected? So the first step here is to that you should complete your course sincerely without missing any class, right? So your attendance will be recorded, right? Then whether you're completing all your theoretical as well as lab assignments. So you will be provided with one material, one printed notebook where you will have all theoretical printed notes. In the end of those notes, you will find lot of printed, lot of questions, interview question, practice question, numerical question, lab question. So you should be solving all those assignments, completing all those assignments in the given time. Okay. Second step, is to clear all your internal tests. So there will be many internal tests plus one final test, right? And then you will have mock interviews also. If you are qualifying with good marks, so we don't want you to like get a 10, 90% marks or 95%. So there will be one cutoff. So if you are eligible, if you are if you are getting that cutoff, your test is clear, right? And whether you are qualifying mock interviews also, there also we will have one cutoff. So if you get a 8 out of 10, definitely you are qualifying that mock interviews, and then you will be sent to real time interview, or mean you will be provided with the opportunity, right? Because we also don't want you go to some interview and you fail there, right? So we will see that whether you are prepared or not, you are ready or not, then only we'll send you to the real time interview, so that you will also get confidence, and you will also not miss, you will also not keep on missing opportunities, because we don't have abundant opportunities, right? It is not like a IT jobs. You might have seen in colleges, usually IT jobs, how recruitment happen. They'll come from truck, right? And they'll fill all students in truck or not, right? That is called as mass hiring, right? There is one terminology in IT recruitment, that is mass hiring. So they'll fill all truck in like 1 lakh 2 lakh salary, 2.5 lakh salary, like that they will go. But that kind of things does not happen here in VLSI. Let me tell you, this is a big difference here between that domain and this domain, right? Because those domain, if you know only C++, one or two languages, easily you will get selected, right? No technical knowledge required, no subject knowledge required there. If you know better, know about this, right? But here you have to be good in subject knowledge plus little bit programming knowledge, and you should know how your critical thinking ability is, how good it is, right? It is also important. So interview preparation session will be given, right? So appear for all interview with hiring partner. This is the final last step. If you clear all this step 1, step 2, step 3, so you will reach step 4. Is it clear? Clear? Any question here regarding placement process, how placement will happen? Any questions? Okay. So this I have just discussed, right? Chip fabrication and chip design. The first thing which I have discussed is this thing only, right? So I have already discussed that chip fabrication involves manufacturing of silicon chips, or it is called as semiconductor chips, right? So that is chip fabrication. What is chip design? So the design which is done before fabrication using what? EDA tools, because we cannot design on pen and paper method, right? So we need EDA tools to design this complex billions of transistor design, right? After getting it designed, it will go to fab lab. So what are those fabrication labs? So those are TSMC, Global Foundry, Samsung Foundry, Intel Foundry. So these are all what? Having the foundry. So these companies are called as foundry based companies. So these, what are fab companies? TSMC. TSMC holds the major share of market, around 70 to 80%, 70, around 70 at least. 70% market is held by TSMC. Then we have Global Foundry. Then we have this Intel, Samsung. These all company have what? Fab labs, where fabrication happens. What is fabrication? What is fabrication? What is fabrication? Anyone? See, you might have heard, if you go to any clothes shop or boutique, right? Or some clothing shop. Mostly ladies will go, right? What they will call? You will ask, right? What is the fabric material? You will ask or not? Or even men will go. So they will ask, what is the fabric material? Why you call it as fabric there? What is that fabric word? Because if you see, if you have you visited handloom, any handloom? Have you seen any handloom? Saris and other clothing items will be what will happen in handloom? Have you seen anyone? Right? What happens in handloom? Weaving happens. How many threads are there? Many threads will be there or not? If you have seen handloom, that wooden handloom. But all those threads are same threads or different threads? Different color or same color? Different color. Whether same thickness of thread or different thickness of thread? Different thickness of thread. Whether same material of thread or different material of thread? Different material. Some jerry thread, some silk thread, some nylon thread, some cotton thread. It will be mix of those or not? That is why it is called as fabric. Anything which is integrated using multiple different things is called as fabric. Now the process of making a fabric is called fabrication, right? Similarly, from that thing only, from that process only, we have taken inspiration, right? And we came to this word fabrication. But here what is happening? Fabrication means what? Integration of silicon layers, substrate, polysilicon, n diffusion layer, p diffusion layer, metal layers, all are different thickness, different color, I mean different material. All these are integrated at right time, at right amount, is called as fabrication process. Now it has some process. Process means you take one base material which is called as substrate. In that substrate, if you dope it with some impurity, right? What is that? It can be trivalent, it can be pentavalent. It can be acceptor based material or donor based material. So you can use, let's say I will use what? To create a N type, I will use what? Pentavalent impurity. If you add pentavalent impurity, dope it with pentavalent impurity, you will get what? N type material or not? Here. So to do this, you need to first dig out or not? Dig out this part, right? So for that purpose only, we have etching process, right? What is etching process? So you have you worked on PCB layout in labs, in colleges? Have you drawn PCB circuit on copper clad? Have you drawn? You haven't drawn? You haven't modeled any electronic circuit? So in that, if you have seen, I mean, you can watch in videos also. So there will be one copper clad, right? What is the process of PCB? I'll tell you. There will be one copper. Have you seen any PCB board or not? At least you have seen PCB board, right? Green color PCB board. That is lamination actually. Inside that green color, there will be circuit made up of what? Copper. Some copper and some components will be mounted on top or not, right? That is nothing but PCB. Now how we are getting that circuit on top of that PCB? So you take one copper clad. Copper clad means one sheet of copper. So this complete region is covered with copper, right? Now what they will do, what we will do, so I will draw some connections. Let's say I'll draw like this, right? I will draw like this on top of copper with some marker pen, right? Permanent marker, something like that. So what is this? Why I am drawing like this? It acts like photoresist, right? So I have drawn this wherever I want what? Interconnect. So this acts like photoresist. So it resists photons. That is why it is called as photoresist. Now this copper clad, I will mix in one chemical solution, ferrichloride solution. Right? You take one bowl, take ferrichloride solution and mix, dip into this ferrichloride solution. Now bring it under the UV light. You can do this at home also. How to get UV light? You don't have such device to get a UV light. So free of cost, sunlight, right? You bring it under the sunlight, sun rays. So because sun rays have UV light also, you bring it under the UV light. Now what will happen? In contact with ferrichloride solution, the rest of copper clad will be washed off, right? This gets washed off. Now what will be the remaining part? What will be the remaining part? Only that network which you have drawn like this. So this copper remaining part will be for this network only. Rest of the copper is washed off. Yes. So this process is nothing but called as photolithography process. Photo means under the photons it is having chemical reaction and rest of the copper is getting washed out to get that network. So that process of getting washed off and having that network is called as etching process, right? So that same process is also here in fabrication labs also. But since it is in nanometer technology node, which is very complex, right? If you have visit any, there is in ISC Bangalore and the IIT Bombay, there are fab labs. If you get time, you just create one pass and you can visit there. You'll find that it is very highly complex process. So if you go there, you have to wear some jacket, complete one jacket, so that your hair, your dust particle should not come inside that facility, right? You will be there will be one sanitary process also, right? Sanitation process for you. So that much, even these chips are getting fabricated under some atmospheric region, right? So there will be some constant atmospheric region, humidity, air, pressure, everything is controlled. Then only you will get that perfect fabrication process. Whether any brain is used there, yes, of course. To develop those machine to have proper setup, yes, brain is needed there. Once it is set up, once Fab Lab is done, created, setup is done, so no more brain work is required. Design comes, you will dump the design, you will get fabrication started. It is like a printing process. Understood? So what is the important part, important role, right? It is the design work. Before going to fabrication, the design will be the chip design, right? So you need to do the proper designing with PPA, with good or better PPA constraint. What is PPA constraint? Performance. No, for fabrication, we don't have course. Why we need a course on fabrication? We are not developing any machines. Machines are long, it is made already, right? Important part is what? Designing part, right? Designing is the main brain work. Why? Because technology keeps on changing, design complexity changing, application is changing. Someone will need to design washing machine, someone will design laptop, someone will design mobile phone, someone will design some satellite chip, someone will design some military chip. So every design is different or not. For that you need good knowledge on subject, network subject, right? Performance. So those designs, not on designing is not sufficient, that those designs should also be constraint driven, right? Means best constraint we should get, means best performance, low power consumption, and in smaller area, right? Performance, power and area constraint. Performance means what? So whenever you go to shop, you will ask the owner or not, shop owner or not, like what is the performance of this phone? What is the RAM of this phone? How many core of processors are there? What is the clock frequency? You will ask these features or not. What is the memory it is giving? What is the battery backup it is giving? why heating issue is there in your phone. If you see, there are OnePlus phones and there are some other Chinese phones also. Usually they will have high amount of heating issues. Why they are having high amount of heating issues? It is purely based upon what chip is designed inside that. Whether the chip is perfectly optimized or not. That is why it is having heating issue. One of the reason, design issue. Other reason can be what kind of IPs, what kind of components it is using. Okay. So if you see iPhones, some flagship phones, Samsung S24 Ultra, right? So there are some flagship and good phones which will have less heating issue if you see compared to these phones, and very robust. Even though it will have heating issues, but there will be no degradation in performance, right or not? If you use any Chinese phone, you might have observed, right? Or not even Chinese. If you go to lower margin, I mean lower prices of lower price segment of Samsung phones, like 10,000 and 15,000 range or mid range, we'll say 15,000 is a mid range phones. Less than 10,000 is a lower range phones. You will see that heating issue is there, right? Whenever there is a heating issue, what will happen in your phone? Phone will start degrading its performance or not, it will be lagging or not while opening any app, whether any app will be opening very smoothly, no, right? Also, you observe, you take your phone outside in traffic where lot of people are there, right? Crowd is there and sunlight, it is summers. That time also you observe your phone is lagging or not, it is behaving differently or not, performance is degrading or not, battery is draining faster than usual time or not. When your phone is in rest, you are sitting at one position and just using your phone, you'll see that battery draining rate is less compared to if you are in traffic. Why that is happening, right? All these things we will learn in physical design, physical implementation, very important, right? Okay. So what are the tools we are going to use? Okay, I haven't told the design companies, right? So for this designing the chips, lot of companies are there. Qualcomm, Broadcom, right? You can also name few. Nvidia. So Nvidia makes what? Anyone? Graphics chips, right? Qualcomm makes mostly mobile processors, modems. Broadcom also makes modem, connectivity based, network based chips, gaming chips. Yes, nowadays they are building gaming chips. Intel is famous for laptop processors, right? Any other? MediaTek is also like a mobile phone processor. Now we have one more company, that is what nowadays they are also building what laptop processor, that is AMD. So AMD, what is the processor name? Radeon, right? AMD processor. Now they are also competing with what? Intel. That is why Intel is dropping, because of AMD chips are more in use in laptop processors. Okay, so these all are what? Design based company. Out of this, except Intel, right? Except Intel, all are only design based company. Only Intel has both design company as well as fabrication lab. All these are Qualcomm, Broadcom, Nvidia, MediaTek. These examples are what? Called as fabless companies. These are called as fabless companies, which does not have any fab. They are only focused on designing challenges, right? They are designing, developing a lot of different products. You know what are these people are building? Snapdragon processors. Broadcom building lot of connectivity and networking based chips. Nvidia is also building what? Graphics, gaming chips, right? MediaTek is mobile processor. So they have some segment, right? Similarly, Samsung chips are there. I mean, washing machine chips are there. Air condition chips are there. Your smartphone chips are there. Those are also developed and designed by some companies. These are some examples. There are many product companies, right? Next. Next is how we are going to design this using EDA tools, right? How fabrication happens, they have different set of tools here. We will not focus more on that. Our work is to do chip designing, right? So here we have lot of EDA tools, like I said, we have ICC2, we have design compiler, Innovus and Fusion compiler. Recently, Apple launches its N1 wireless chip. Yes. Okay, to design these complex design, what we require? We require EDA chips. So major EDA companies, right? I will say EDA companies. Can you name any EDA company? Synopsys. Synopsys, Cadence. Earlier there was Mentor Graphics also. Now it is changed to what? It is, yes, it is changed to, okay. So these are all what? So there are other companies from I mean other products from EDA products from Anisys, right? So these are all what? CAD companies, right? These are all what? CAD companies. Their work is to design better CAD tools, development of CAD tools. Now, what are all CAD tools? Based upon requirement, CAD tools are available. If you are doing synthesis, so you have DC from Synopsys and Genus tool from Cadence. Both work same. Both are for synthesis only. Just some commands and some GUI is different. That's all. Work is same. If you are, if you want to do what PNR, place and route, or physical design, floor planning, so you have ICC2 from Synopsys and Innovus from Cadence. If you want to do STA, static timing analysis, right? Prime time is from Synopsys and Tempus is from Cadence. So work is completely same. But what is the difference? Some command and GUI representation is that's is different, and some plus and minus features. Some features will you won't find in Synopsys. Some features you will find in Cadence. Some features you won't find in Cadence. Some features you will find in Synopsys. It's like that. So these are like competitors to each other. Okay. So EDA companies also hiring physical design engineers for development, for testing the chips, but these are not design companies. These are not, don't get confused by design companies. What is the product they are developing here? CAD tool, not designs. They are not developing any product designs like washing machine chips or laptop chips or mobile chips. No, they are not design companies. Is it clear? So what are different types of company? One is fab based company, one is fabless company, one is EDA companies, right? Majorly the companies can be segregated in these sectors, right? Fab means, you know, TSMC, right? Intel, Samsung, Global Foundry, right? Fabless means Qualcomm, right? And what is it? AMD, right? Anything else? Nvidia, Broadcom, EDA, Synopsys. I'm giving some examples. Cadence. These are EDA based companies. Okay. So these are the difference between these companies. So the different process is there. Process means what? Different flow we are following to complete this. Fabrication will follow photolithography, etching, doping process, as I have told. What is fabrication, right? In chip designing also we are following some flow. So starting from what? What is the first step of designing? That is nothing but RTL code. How many of you know HDL language? You know, hardware description language, Verilog or VHDL. You have studied in college? How many? Just raise your hand. Miss, I will not ask any Verilog question. Just raise you have done something or not done. VHDL or Verilog, anything. Okay. So the first designing step is RTL coding using Verilog code, using digital design Verilog code. Okay. Then it is converted into gate level netlist by what process? Synthesis. That is called as synthesis. So till synthesis, the flow is called as front end flow. Whatever domain comes in the front, in the first part, is called as front end, right? Like RTL coding, design verification, synthesis, logic designing, all these are front end. Synthesis not is completely front end, it is part of back end only actually. Okay. After synthesis completes, then main work start. That is called as physical implementation of design. Till synthesis, what was happening? Your design, whatever your transistor design or your logic design was logical, all logical, right? Physically no parameter was there, whether width is defined here, whether channel length is defined here, whether any length or electrical parameters are defined here. Before synthesis in RTL code, in Verilog code, you define electrical parameters? No. You define width and length? No. So this is completely what? Logical. That is why it comes under front end. So what comes under back end then? So it is purely what? Physical implementation of your design. Physical implementation means what? Your real design. Your real design which is going to fab, right? So you draw and like this. Whether this will go to fab, what does this mean? Nothing. There is no physical parameter. Now you will say that, okay, I will convert this into transistor, right? This is like NAND, I will say, or let's say not. You will say not. So this is inverter. So you will say that, okay, I will draw like this. This is having two transistor. Whether this will go, this information will go to fab? No, right? This has to be converted into what? Some layout form. Layout means what? Using fabrication layers. Like what? Substrate, N diffusion, P diffusion layer, poly, silicon dioxide. If you use all this layer and get the device, so that is called as layout. So your design should be in layout form. So that will be sent to what? Fabs. So what is the final output? Once physical design is also completed, final output is called as, in design, it is called as GDS2. What is the final output in chip fabrication? Silicon wafer. Like I said, once it is fabricated, it will be cut into smaller chips, which will be packaged into one black box, right? And then it will be mounted on PCB, right? So what is the final output in chip designing? GDS2 layout, right? So layout is nothing but it is layer by layer fabrication combination. So all physical layer information and its connectivity with metal layers, all information is present in GDS2. It is a graphic design interactive uh, representation, okay, which will be sent to fabrication lab for fabrication. So what are the dependencies in chip fabrication? So foundries manufacture chips based on design files. So these chip fabrication is dependent on chip design. If they do not get GDS2 file, so no process will start. Okay. Who are the dependencies? Designers rely on foundries. How they rely on foundries? Foundries need to tell the designer or not what are the rules of this particular technology. If foundry is developed in one technology, let's say 14 nanometer or 28 nanometer, let's say we'll take two examples here, 14 nanometer, 28 nanometer, right? So this is a completely foundry dependent length, right? This is channel length, of course. So any foundry is developed based upon these technology nodes or not. right? 14 nanometer or 28 nanometer. With respect to these technology nodes, rules will change or not? Physical rules. It will be different from these rules or not? Completely different. Why different? Because machineries and setup, is it same? It is also what? Different or not? It is different or not? Yes, it is different. That is why foundry people or fab people needs to provide some information, some rules or some restriction, right? Some limitations to whom? To designers. So that those restriction or those rules they can include while designing the chip, right? It is similar to, suppose you went to what, carpenter, right? You went near the carpenter, right? What you are asking, I want one bed to get, or sofa, so I want sofa to be designed. So whether you are going to give some specification or not, right? Who is the designer? Carpenter. But you can give some inputs also, like I want this much of height, this much of length, I want gold material sofa, I want silver material sofa, I want gold plated, I want wooden, I want iron, I want steel. All this specification who will give? Client will give. You are the client, you are the market, you are giving that order. Who is designing? Carpenter. How he will design? Okay. So you asked him that, you went to local carpenter and you asked him that I want 10 kg 10 kg gold used sofa. Means 10 kg gold must be used in sofa designing. Now what that carpenter will say? Okay, I'll give you 10 kg gold. Hmm? Or that carpenter needs to check its foundry, right? Designer is what? Carpenter only. Carpenter will first do one or two calls to some jewelry person, some person, that I want this much of 10 kg gold, whether available or not, whether it is accessible or not. If that person says yes, it is accessible, after giving this much of amount, then only he'll give. Not in one go also. First month we'll give 1 kg, second month 2 kg, like that we will give, not completely. Then he will tell to you or not, yes, it is possible, we'll take this order, right? So it is designer's duty to check the rules which is coming from foundry, whether they have given proper rules or not, or you are following or not during. So that is why we call that dependencies are both ways. So what is GDS2? Like I said, it is nothing but a layout of the design using what? Silicon layers. So different layers, different types of base layers are there. So this is what? Diffusion layer. You have seen layout. Have you seen layout? You know layout, CMOS layout, right? So these are polysilicon layers. These are metal layers. These are contacts. All these physical information. This will have specific height, weight, everything will be defined. What will be the spacing between these two poly is also defined. That spacing is nothing but one rule which is given by foundry. Suppose there are two polysilicon layer. This is one polysilicon, right? What is the minimum spacing you should follow? Whether you should follow any minimum spacing between these two poly layers? Yes or no? Yes, of course we should follow. You cannot just stick these two polysilicon layer near to each other, right? You cannot create like this also, too far from each other. So there are some constraints, some limitation. Who will tell you that constraint? Who will tell you max and mean limit? Who will tell? Foundry will tell, right? So they will be giving us some set of rules. Those rules are called as DRC rules, design rule check rules. Is it clear? So that this file will go to foundry. So okay, we'll start a SIG design flow. We'll take 10 minutes break and then we'll resume. Classic design flow is nothing but a complete project design cycle flow. So whenever we are designing any chip, it will follow the complete design cycle flow. What is the first step? What is the next step of design cycle? What is the next step? And then we will have physical design. Physical design is not the first step. First is the logical designing. That is by RTL code. That we'll see after break. So let us take 10 minutes break and then we'll resume. So we will cover Krishna some ASIC design flow and then we'll take some questions. Also, I will tell you the market situation and what are all types of jobs available and different domains. What are the opportunities? What is the difficulty level? What should be your preferences? All those things I will discuss after this flow. Yes, we'll resume from here. So we'll start seeing what is a SIG flow, a SIG design flow. To design anything, so we have completed fabrication, we have seen overview, right? We have seen core structure. Now we will see what is the design cycle. So we'll discuss about the designing part. To design any product, what we require first thing? To design anything, we require, what is that requirement? If I tell you to cook something, right? Cook a Maggie. What is your requirement? You want to cook something. Let us cook a Maggie. What is the requirement? Ingredients. How much you require? You require 100 kg of Maggie packets, 1 quintal, 10 kg masala. How much is the requirement? Now the second question comes or not? So you require, if you're cooking for one person, so you require one packet. If you're cooking for 4 person, you require 4 packets, right? Then second thing, water. How much water requirement, right? Next, where you are cooking, what are the additional support you require? Means machine or induction stove or wood or charcoal stove or gas stove. What is the support system and how you are going to use it? What is that requirement? Next, anything else which comes in your mind? Just simple. Think about Maggie cooking. What are all requirements? That's all. Maggie will be cooked. Anything else? Hmm? Very important thing we are leaving here. All I've told you. Hmm? Consumer what? Oh, who will eat? Eating person should be available. It is also available. Time. Very important specification here is time. If you cook it for 10 seconds only, can we eat? Is it prepared? If you cook it for 1 minute, is it prepared? No. If you cook it for 2 minutes, is it prepared? Hmm? No. As company claims it is 2 minutes noodle, it never cooks in 2 minutes. Everyone knows that, right? It always takes more than 2 minutes. So time is also very important specification here. So what you understand from here, to design anything, not only Maggie, you take anything, chair, bike, car, or costumes, fashion designers, they will say, right? Any design you say, all starts with requirement first. Requirement is there or not, demand is there or not, right? Then comes what? Specification, right? Let's say requirement itself is not there, then what we need? Suppose you became a sannyasi, right? Your requirement is just you will eat normal light food. You don't want big stuff to eat. You are happy with that food also, right? Very well satisfied. So you are living a saint or what we say sadhu's life, right? So your requirement is that much is not there. So then how I will sell you if you become like this? I cannot sell you anything, right? In that case, then what comes? Then comes marketing, right? How to market, how to bring that thought inside you that you need that requirement. Can you give an example in Indian market? You know it. Daily you will be hearing something related to that. That is iPhone, right? iPhone requirement. Does everyone require iPhone? With normal phone and iPhone, what you will do? 3 to 4 tasks only daily, not more than that. YouTube, calling, SMS, social media. Except that, and sometimes if you go outside, sometimes we'll take photographs also. Apart from that, what you will do extra? There is no requirement. If you want these features, you can get it in less price also with same quality, almost near to same quality. Of course, there are other things like battery backup and these things, Whether this requirement is needed for everyone, whether auto driver requires these kind of requirements, whether a coolie person requires these kind of requirements, whether any person who, a farmer person who is working day to evening in farmland, whether he requires iPhone, not required, right? But in India, so major mass, they have seen that major mass does not require this phone itself, this much of costly phone. Now what they have done, they have, using social media, using the influence, they have started using marketing strategy. What is that marketing strategy? To play with the emotion. One requirement is your need, and second requirement is your emotional. So whenever you purchase anything, you purchase because of only two reasons, right? One reason is you definitely need it, you want to use it. And second reason is you are purchasing because of emotion. Emotion driven purchase is victim of marketing. Understanding? So you are if any purchase is due to emotion, like your friend has purchased one car, now you are in that emotion that I will also purchase that same car, more than that car. What is that? Emotion driven purchase. Now your neighbor has built one two-story building. Parents will be talking, they have built two stories. We will also build three-story, right? That is what emotion driven building. So now you are seeing that. So my friend has two pairs of sandals, high heel sandals. I have only the sandal slippers. I do not wear high heels also. Not now thought came, right? I should also have one pair of heels, right? That is what emotion driven purchase. So marketing strategy is very differently. Marketing strategy plays with the emotion of consumer. So that is how purchases and how purchase will happen, right? So if need and requirement is not there, then these companies also require marketing team also. Nowadays, you are, one more example I'll give you. You are seeing phones, right? So earlier days, there was only one camera behind the phone, right? Then there comes two camera, there came three camera, four camera, five camera, megapixel also. Earlier we have 12 megapixel, then we have something around 25 megapixel, then 50 megapixel. Nowadays we are having 100 megapixel cameras also, 200 megapixel camera also, right? What is that? If you take picture from 200 megapixel camera, 100 megapixel camera, take picture from 50 megapixel camera, it is same only difference is size. That is 50 MB photograph. This is 20 MB photograph, 15 or 20 MB photograph. But you will see the picture quality is almost same. Even if you enlarge it, it will be same only. Slight difference may be there, right? So this is also what? Marketing gimmick, right? Because people are seeing that, okay, you have 50 megapixel camera, I'll purchase a phone with a 100 megapixel camera, right or not? People are emotion driven. So every 6 months to 1 year, you will see one phone with some additional feature. We have this thing extra, we have this thing extra. So you will throw your old phone and you'll purchase new phone. So in this last 10 to 20 decades, it is been clearly visible that complete purchases are now driven towards emotion. Right? If you see 25 years back, if you see your parents' generation, unless and until one thing is completely destroyed and completely used, they'll not purchase the new thing. Nowadays, most of the person are having 2 to 3, 5, 6 pairs of shoes, right? 5, 6 pairs of different nowadays bikes also, 2, 3 bikes, 4 bikes, sports for sports bike, for eco-friendly bike, for budget-friendly bike, right? So now things are like this. So if there is no need and requirement, then market comes. Okay. So, so we will talk about not about emotional requirements. We'll talk about the market or needful requirements. So for needful requirements, we require specifications. What are those? by that Maggie example, we have seen some specifications are required. Even in chip designing, we need some specifications or not. What are those specifications? Performance means delay should be less, it should be faster, device should be faster. Second, power. Power should not be like very high power. It should not be high power consuming. Even battery size should not be very big battery size. It should give more battery backup. It does not mean you carry one battery case right with you and you use it for 10 days. So battery size should be also, weight should be also less, right, with more battery backup. Then comes what? Performance, power, and very important, area. You don't want to carry big phones, right? Earlier days smartphones, if you see Nokia smartphone, right, it was very heavy, very thick, and not very comfortable to carry, right? Nowadays we are having very slim and very lightweight phones or not, very compact phones or not, right? So because of chip area, because chip area has been reduced, that is the reason we can accommodate more number of components in that same PC. We have that area. So very important, performance, power, and area. So first thing is always what? Specification. Right. Now the specification is motivated by what? Requirement, need. Right. What is the need? Now we want to design a washing machine. For what? For consumer. So you will develop what? A washing machine chip which will have feature to automate washing the clothes and drying the clothes itself, right? And water also. Water nowadays, if you see in automatic washing machine, water will cut out automatically. We don't have to think about how much bucket of water we need to put inside that, right? So another example, you can see bikes or cars. Now what is the need? What is the need of market, or what is the need of consumer? So so most of the people are purchasing budget friendly bikes which is having better mileage, or we will say affordable mileage of 60 kmpl or 70 kmpl, let's say. So that will be what? Budget friendly, around 1 to 1.2 lakhs you will get easily such bikes you will get or not. Yes. So your requirement, your need is what? Getting into a professional racing sport, right? Then what you will pick? Whether you will pick mileage, you will not see mileage, right? Your constraint, your requirement is what? It should be fastest and better stability, good suspension, all those things you will see or not. You will not care about mileage there, you will not care about fuel there. Why? Now your requirement, your main requirement, need has been changed. According to that need, I will not focus while designing that bike. I will not focus on mileage. What I will focus? I'll focus on other parts, engine, right? Main part, engine, and other stuff like the tires, the brakes, the suspensions. Those should be best or not in these bikes. So constraints, specifications has been changed because of application. Suppose now one chip is there. You know that Chandrayaan mission, right? In Chandrayaan mission, recently they have sent Chandrayaan mission, which is successful. So what is the purpose of that mission? Anyone? Purpose of that Chandrayaan mission? Don't know. Where they have sent? South, yes, South Pole of Moon. Why they have sent? There are many purposes, there are many the objectives. One major or one important objective was to find the traces of water, right? Because they have found that there are some traces of water in form of ice in South Pole. To find that, they have sent that rover, right? In that rover you will find they have inbuilt drill machine, and that drill machine can be controlled from earth, how much we should drill and what are all samples we should collect from there, right? So how that is possible? Because of silicon chip. But what kind of silicon chip? Whether it is predefined design chip or the design can be changed accordingly. It can be changed. Why? Because if you keep a design fix, then we don't have that much of flexibility. So that is where we require what? Programmable chips. Means programmable chips means hardware design itself can be changed. Okay, if you have a washing machine chip or smartphone based chip or mobile phone processor chip, those chips, can you change the hardware design? You cannot change, it is fixed. Those kind of chips are called as ASIC chip, application specific integrated circuit chips. Why? Because it is very specific to that application. Now if you're having FPG or programmable based chips in your spacecraft, what can happen? Or missiles, suppose you have launched one missile in some nation, some country, right? Immediately you found that that country has accepted your terms, what you are asking for. Now what you will do? Still you will launch that. Still missile is already launched. Whether you will allow that missile to fall on that country? No, right? It should stop. So how it will stop? It will not stop once launched. But yes, it can be stopped because with the help of programmable chips. Right? It can be reprogrammed and the projectile motions can be changed for that missile. Those are called as guided missiles. Right? So these are some examples on application based chips and programmable chips. So whatever we are going to learn here, it is ASIC based chip, consumer based chip. 85% of market is of ASIC based chips. It is not military chips or spacecraft chips, because those are what? Not for consumer purposes. Those are for dedicated missions or objectives. So we are not building phones for some mission or objective. We are not building washing machine chips for attaining some objectives or mission, right? So yes, so application specific integrated circuit design flow. So these points I have already covered, right? You can just read out. Nowadays, we are saying that very large scale integration, it is nothing but integration of billions of transistors. So what is the design flow? The first step which comes under design flow is specification, which is motivated by requirements or need. Next is the architectural design. Next, you need to design a block diagram or not. What all systems are required? If you want to design a bike, so you will think or not what all things are required. You require a tire, you require an engine system, you require a fuel tank system, you require a suspension system, you require what? Chassis, the body, actual body of your bike. What will be your body? What material? Right? These are all system or not? What complete design system or not? So all these systems are required in designing a bike. Similarly, designing a chip based on your need. I want to design a mobile processor. What is the need? You require CPU, you require memory system, you require battery management system, you require graphics system, you require digital signal processing system, you require analog to digital converter, digital to analog converter system. Many subsystems are required or not in your design, in your processor design? Yes, it is required. So that is nothing but block diagram, architectural system. How many blocks are there and how these blocks are connected, right? If CPU is there, CPU must be connected with memories, ALU elements and graphics also, right? Because it is processing graphic images also. And connectivity also. Major of subsystem is connected to CPU. That is why we call CPU as heart of processor, right? RTL design. So once this is defined, subsystems are defined, then you will start with RTL design. Each subsystem will be designed separately. See, if you are designing a bike, right, whether all will be designed at once, so there will be wheel engineers who will be separate. Fuel tank or engine designers will be separate team. Then there will be chassis or body or painting chassis body. These type of engineers will be separate. Fuel tank or injector, braking system. These system team will be separate. So they will be designing at their level. By what? So there are some other. Similarly, these separate subsystems like CPU, ADC converters and memories. So separate team will be there, right? So each subsystem will be designed separately using what method? Using programming language called as HDL language, hardware description language, Verilog or VHDL. Okay. So this is what specification with respect to each subsystem: GPU, CPU, ALU, speakers, audio, mic, and this complete architectural block diagram is called as SoC, system on chip. Right? What is RTL code? RTL code is nothing but a programming language, hardware description language. Whatever logic diagram is there, let's say this is mux, 4:4 cross 1 mux, right? We'll talk about 2 cross 1 mux. So you have, how many pins are there in 2 cross 1 mux? How many pins? How many input pins? How many output pins? Online, offline? How many input pins? How many output pins? Two, two input pins and yes, correct or wrong? There are three input pins and one output pin. Here, one, two, three. Right? Select line is input or not? Or output? So this is output. So there are three input pins and one output pin. Okay. Now I want to design this. Right. Design using what? Verilog. Or we can say HDL, hardware description. I need to describe this hardware. This is a hardware. Right. How you can describe this hardware? So there are different modeling styles in Verilog. Those who have studied, they can tell. Right. Those are behavioral modeling style, data flow modeling style, structural modeling style. So most of this RTL code is written in behavioral modeling style. Behavioral modeling style means defining the behavior of any hardware. If I want to ask, yes, gate level structural is nothing but gate level designing, right? It is also called as gate level. Now, what is behavioral? Behavioral, any behavior depends on what? Inputs, right? Any behavior. Outside temple, you will see beggars are sitting or not, right? You go any one of the beggar, go near one of the beggar. You will give something, right? What you will give? Some money. How much you will give? 1 rupee, right? You give 1 rupee to that beggar. What that beggar will do? Beggar will give you 2 rupees to you, okay? And tell enjoy. If you give 50 rupees to beggar, what beggar will do? Happy. If you give 500 rupees to beggar, beggar will be overwhelmed and give you lot of blessings. Very good, very good. Next week also you should come. Like that beggar will say or not. So why this is happening? Behavior is same or different? Different. Why it is different? Based on inputs, right? Based on inputs. So if inputs are changed, behavior is also changed. So what inputs? What are all possible inputs? How we can tell? What are all possible inputs? It is 2 to the power n possible inputs. How many total number of inputs? 3. 2 to the power 3 is 8. So there are total 8 possible inputs. So you can easily draw what? Truth table. Right? You can draw truth table for 8 possible inputs or not. You will get desired output. Based upon these inputs, it will behave. What is the behavior of 2 cross 1 mux? Anyone? How it behaves? It behaves based on select line. You can write the Boolean expression also. What is the Boolean expression? S0 bar I0 plus S0 I1, right? This is nothing but the 2 cross 1 box. So what is the behavior? Can anyone tell me? If behavior means what? If you have given 1 rupee to beggar, beggar gives 2 rupees to you, right? If you have given 500 rupees to else, if you have given 500 rupees to beggar, what is the output of beggar? Blessings, right? That is what you are writing the behavior of that beggar or not. If you give bungalow to beggar, right? What beggar will do? He will make you beggar. That is what output. So behavior is completely changing based upon possible inputs, right? Similarly, you see what you are designing. You are designing a hardware. What are all possible inputs, right? If sorry, if S0 equal to 1, right? Then output will be I0. Else output will be I1. I have written what? Behavior of 2 cross 1 mux based upon inputs and outputs. Number of inputs. 3 inputs, possible outputs 8. Right? So this is the behavior of 2 cross 1 mux. Is it clear? In this behavior code, in this RTL code, do you see any logic? Do you see any logic? Any logical gate, any logical circuit, no connections, right? There are no connections defined. There are no logical circuits defined. Is it defined? Not defined, right? Then how we can fabricate this code? Is it possible to fabricate it? No, right? But before thinking about all this, what is the next step you should do? Once you have defined the behavior, you should be verifying it. Verification. That verification is called as design verification. So there are multiple tools like Questa Sim, right? They'll be using different languages, System Verilog, UVM, these kind of languages they will use to design what? You do the verification, not design. RTL is already designed. So you will do the verification. Verifications are done based upon test bench you are writing with proper test cases. So what are all possible test cases? Total number, max number of possible test cases can be found. The number is 8 because it is having only 3 inputs. What about if it is having 100 inputs? It is 2 to the power 100 or not? How much is 2 to the power 100? It is in GBs, right? It is big number. So there will be number of inputs here. So for these numbers, you cannot give all test cases each one by one. It is a tedious task. That is where design verification is required. So they will have protocols called as protocols or strategies to give all possible inputs. To that is called as coverage. Whether we are able to have that complete coverage, right? See, suppose there are 2 to the power n, 2 to the power 3, 8 possible inputs. You have verified your 2 is to cross 2 cross 1 mux for 7 inputs, except one input, right? What is 7 means? You have for 0001, 0010, 0100, for all 7 you have done, but you haven't checked for this possible input, triple one. Can you tell that your design is perfectly passing? Is it passed? Yes, it is partially passing for 7 test inputs, right? But we don't know whether it will pass for this input or not. Why? Because we haven't checked. So what is the coverage? What is the coverage here? What is the coverage? We can say that if it is 8, so around 94%, 93 to 94% is your coverage, right? You are very sure that 94% of hardware design is passing.
because for 7 inputs you are getting desired output. It is passing. How much? 94%. But you are not sure about 100%. Why? Because till now some inputs you have left to test. That is very important part in design verification, to have 100% coverage. Very rare, very ideal case, we will never get 100% coverage, because if you have hundred and thousands of inputs, there will be one possibility which you will leave, right? Which is not, it is not possible for to check every input. Okay, so this is about design verification. So after RTL designing, the next step is RTL verification. So they will have these kind of simulators. Some Xilinx, Vivado tools are there. Using those simulation, they will create waveforms. At what point, at what test input I am getting signals, whether there is a delay or not. All these things they'll check. Right. Next. So after verification, after verifying, can we send it to fabrication? Your RTL code is verified now. Can we send it to fabrication? Of course not. Why? Because it is a behavior code. There is no logic inside. It is not defined in terms of logic. What is going to get fabricated on silicon? It is devices, silicon devices made up of silicon layers, substrate, P plus, N plus, poly, right? So for that reason, we require another stage called as synthesis. It is also called as RTL synthesis. Right? Synthesis is nothing but the breakdown of, or you can say translation. Right? It is similar to you eat food. Right? After eating food, what happens? That food, it mix up into your bloodstream immediately. What happens then? Food starts. What happens in digestion process? You might have studied in schools, right? It breaks down your food into small, then it extracts or it translates into, breakdowns into glucose, right? And that glucose is absorbed into your bloodstream, right? That is why we will say, diabetic patient will say glucose is high or sugar is high. Why they say that? Don't eat rice, don't eat sweets, because sweets breaks down in faster rate and it generates more glucose, right? That is why they say don't eat that. Eat those things which takes more time to break down into glucose with time. That is more healthy, right? So that is called as translation, breakdown. Here also some high level language is there, RTL code, behavioral code is there, which does not have any logic, gate level logic. Meaning, to translate that into gate level logic, we require this synthesis stage. So complete RTL code will be break down into what? Corresponding logics, like what? Mux. Some will be converted into inverter. Some will be converted into D flip flop. Suppose if S0 is 1, Y equals I0, S0 else S0 is, sorry, S0 is 0, S0 is 1, then Y equals I1. So this is what? If else statement or not. Mux is nothing but what? If else. So this if else statement will be converted into mux logic in synthesis. After, what will be the output? Mux logic, right? If we convert it into mux logic. Whether it is technology dependent? Yes, it is a technology dependent process, synthesis. Why? Because the libraries we are using, those are called as standard cell libraries. Those are technology dependent, coming from vendors, right? If you are working on 14 nanometer technology, so this mux is designed using what? 14 nanometer. So from synthesis onwards, it is purely what? Technology dependent design. Whether we can call it as a physical implementation, whether it is a physical design, whether it is a physical implementation, no, because there are no physical information yet You haven't placed anything on chip right now, on your chip area. Okay. So till this part, yes, we will get a netlist. That netlist, the output netlist is called as gate level netlist, GLN, right? Where you will have all gate information. There is no behavior meaning now. That is translated into what? Gate level circuit. All gates. So how many gates? 2 is to 1 mux. You require 1 mux, right? How many AND and how many OR and how many inverter? 2 AND, 1 OR. 1 inverter is required to design 2 cross 1. So all this information will be present in output of synthesis, gate level netlist and its connection. Okay. So this is synthesis. See, as you can see, yes, we call it as golden netlist, not RTL, but we can call it as golden netlist. Okay. So you can see it will be converted into this logical connection, logical circuit. Okay. So it will be, you can see that there are some ports also, gate level netlist. You can see example. You'll see library names and inverter. It will show the connection. Dot A means pin. Q means net name. So which pin is connected to which net? It shows the connection. Right? So DFT is part of synthesis only. DFT and synthesis go in parallel. So once there is one round of synthesis completed, they will include DFT also. DFT is nothing but design for testability, which improves testability of design. Right? It helps us to find the stuck at fault. Suppose your design is malfunctioning, it is faulty, it is not giving right input, right output. How you will pinpoint where exactly fault is coming? See, if we talk about just mux, it is very easy to find out. But if we talk about big processor design, SoC level design, which is having billions of transistors, if you are getting one wrong output at one pin, how you can identify where exactly fault is happening? That is why you are getting wrong output. That is with the help of DFT block. Yes, they need to understand some basic, that's all. We are not doing any DFT stuff. Physical design engineers are not doing. There is separate DFT team for this. So they will have scan chain blocks in DFT. Those are called as scan blocks. So after all this, you will get gate level netlist. From that stage, your physical design process will start. Physical implementation process will start. So what is physical implementation means? Whatever logically present means till this point, whatever we have discussed till this point, it is called as front end, right? Your RTL, your design verification, right? And some parts of synthesis also. Synthesis is also back end. So whatever programming part, hardware description part, that is called as front end. After synthesis or from synthesis, it is called as back end. So once synthesis is done, so we'll start implementing physical design, right? The first step in physical design is called as floor planning. Because you have to place now each and devices, objects, you have to make interconnects physically, right? It should have dimensions, it should have spacing, everything will be there. Electrical properties will also be there, noise will be there, crosstalk will be there, lot of things will come into play. So for that reason, first thing is what? Area requirement. Suppose you want to build a house. How you are going to build a house? You need a plot or not for building a house based upon requirement. How much plot is required? Whether you are building a mall or a house or a flat, based upon requirement, you will decide area, right? So you have decided this much of area. Then you will build a compound wall or not, right? So this external compound wall is called as die boundary, right? Internal one is called as core boundary. What are all these? These are ports, right? Inputs and output ports. What are all these lines? These are standard cells. Standard rows. These are all what? Standard. It is like a marker. marker for standard cell placement. Suppose you have seen, if you have went for purchasing a plot, or if you have seen parents plot also where you are living, right? It is all what marked into equal spaces or not. It is divided into equal spaces or not. Some 800 square feet or 1200 square feet, all plots, right? So some people will buy two plots, 1200 plus 1200 like that, right? So, but each and every spot is equally distributed. So like that, there is a marking of standard row, which is with respect to standard cell height only, which is integral multiple of standard cell height. That we will understand during advanced session also, how this is done and these things. Okay. So after this, you are going to place what? Macros. What is macros? Memories or bigger elements in your block. Right? Suppose you are designing a block, you will have some memories, some other components, some sensors, some IPs. So you have to place bigger blocks. Right? How you are going to place, very important here. Suppose this is your core area. This is your core boundary. This is your die. Now I have four memory elements. These are my four memory blocks, memory IPs, intellectual property cells, right? If I place these memory cells like this, is it okay to place like this? And here my ports are there. These are my ports, inputs and output ports. Can I place macros like this? Why? What will be the problem? Any problem if I place like this in center? Okay, let us make it somewhat easier. I will give you another thing. So you have purchased one new flat, right? In that flat you have lot of rooms or not? Bedroom, kitchen, something else, some hall. Now here you have decided to place what? Sofa set. Where you are going to place this sofa? Here is your entrance, right? Will you place sofa here? Will you place sofa here? Hmm? Where you are going to place? Where? Somewhat corner like this you will create, or here, right? But not at the center or not in front of gate or not. Why? Because it is blocking ports, right? Because it is blocking ports. So it should be in corners or side. Why? Because these are bigger blocks. If you place, let's say there is no entrance also, but even if you place at center, so every time you want to walk from here to here, you have to walk like this or not, right? But this is empty space, means you can walk diagonally or not, right? It is convenient or not compared to first one. So best place to place this sofa is in this corner, right? Better or not? So now this is also not sufficient to decide to place sofa, right? So if you see sofa, right, it is something like this. So I'm just drawing the skeleton of sofa. So this is your what? This is your, let's say, sofa. Now this is sofa's face where you are going to sit, right? Whether you are going to face this sofa's face in front of wall, hmm? No, right? Why? You have to jump and sit there. So orientation is also very important. What is important here? Orientation. Proper orientation should also be given. So if you are placing sofa here, 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 right? So proper orientation should also be important, not only the placement of sofa. Understood? So these are some one or two parameters I am explaining here. There are many parameters which we need to understand while placing the devices.
So there are many devices. One is called as macro, some are standard cells, right? Based upon the design demand, we have to place the devices, right? If you place macros like this, what will happen? Maybe some cells, some standard cells, small cells will be sitting here and some sitting over here. So lot of routes will go from here or not, from channels, from here, from here. What will happen in this region? Congestion or not? See, there is one single road and lot of vehicles are taking shortcuts on it, going through this channel. What will happen? Traffic jam or not? Why? Because resources are less, roads are less, and vehicles are more. So routes, cell routes are more in this channel, but tracks are less, right? So what will happen? Congestion, right? So this kind of placement is not accepted. So there are such type of these are called as guidelines. So you'll find many guidelines are there which we need to understand. Some are critical, some are complex. We'll understand that during advanced session. So next is placement stage, right? See here, not only macros are placed, then you have to place what? You have to do power planning also, right? These devices should be given power also, right? VDD and VSS supply. So that is also important. That also I'll discuss in short here. We cannot cover all the things in one session. Small in one line I'll explain. So you should have proper distribution of supply, right? Power planning is nothing but proper distribution of supply. So at your home, I will give you one small example only. At your home, your TV you have placed here. Where should I place socket? Here or opposite to TV? Why not opposite to TV? Hmm? So what will happen if it is long? If length is more? Voltage? Voltage drop will happen. Good. That is correct. Voltage drop. If voltage drop will happen, what will happen? Less current will flow. And what else? Why voltage drop is happening? If length of the wire increases, what happens? Oh, of course, between what happens? Why voltage drop? Because resistance increasing or not. If this happens, what will happen? Your bill will increase or not? Because this resistance will add into effective resistance of load. Earlier, you are having one TV only at your home. You are not using fan, light, anything, only TV, right? So you have one load. But if you have more length of wire, what will happen? Load resistance will increase or not? Your RL will increase or not? Load resistance. So whatever wire resistance is there, it will add up to your effective resistance, right? If you have more length means the effective resistance will go high, your bill will also go high. Your meter will run like Usain Bolt, right? That is why we need to do proper power planning, proper power distribution, so that your IR drop should be less. Very important. So very complex also this stage. Power planning is very complex stage. So you'll understand it will take a lot of sessions actually. Okay. So next step is placement, right? What happens once you placed macros, bigger blocks, and you have created ports, you have defined the area. Next step is placing standard cells, the remaining standard cells, smaller cells like AND or full adder, right? MUX and D flip-flop, other flip-flops, some IPs, clock gating cells. All this will be added during when? Placement stage, right? It is a placement of standard cell in correct position. See, now you have divided your complete area into small plots, small area. But if you are not building your house in exactly same plot, what will happen?
illegal, right? It is a illegal placement of house. Similarly, if you are not placing the standard cell exactly on site rows, then what will happen? Illegal placement. On top, you are seeing the course placement representation here. On second one, you are seeing the legalized placement. You can see on the first, it is what? Illegal placement of these standard cells, which is not on site rows, right? The second picture you are seeing here, these standard cells are legalized, means exactly placed on site rows, which is meant for that. What is site rows, right? So site rows are nothing but the height is defined from foundry itself. This unit height, unit core height, and unit site height, and unit width height. This is coming from technology file, coming from foundry. This information is coming from foundry. They are telling us that this should be your 1 unit site height, 1 unit width height. So whatever your standard cells are there, standard cell width, standard cell height, it should be integral multiple of these site heights. So this is one rule, and this rule is coming from foundry, right? And this is purely based upon which tech node we are using. Suppose if you are using 14 nanometer, 28 nanometer, right? Of course, this width and height, let's say it will be x1, x0. If you are using 7 nanometer design, so this is like x1. So x1 is greater or x0? Of course, x0 will be greater. Means here also you will have site height and site width, and here also you will have site height and site width. But both will not be same. This will be less than this. It means, let's say there are 1, 2, 3, 4, 6, right? 6 cell sites. If this is for 14 nanometer. If I want to define sites for 7 nanometer, what will happen? Instead of 6, I can get what? I can get what? 12 sites, right? Now, what is my width and what is my height? It is, of course, less than this or not. Here I am getting 6. Here I am getting how much? Here I am getting what? 18, right? 18 sites. Understood? So 18 means what? More number of cells can be placed here. More cells can be accommodated here as compared to this one. Understood? How it is linked? You will understand more in after basics and advanced session. So then comes CTS, clock tree synthesis. Once you have placed all standard cell, sequential cell, now the next important task is to provide clock to all sequential cells. Now how that should be provided? Whether you can directly connect all clocks to all standard cell, is it good to do? Why? Suppose you have clock port like this, and you have lot of flip-flops. These are all flip-flops. Whether I should connect like this directly from clock port to this flip-flop, is it good to connect? What is the issue? See, it is similar to like there are lot of homes, plots, right? They have built house in rows like this. So I want to develop road. Should I create, this is the main gate of colony. From here I will create one road like this to this home. One another road from here to here, point to point. One road, separate road here to here. Separate road to your home. Separate road to your friend's home. Separate road to your home, your friend's home, right? Is it good? Then what we should do? What we should do? It's better that we create one common road that we will call it as main road, and from main road we'll distribute
like this or not? From main road, we'll distribute like this or not, and then we will connect what to your homes. This is better or this one is better? Second one is better. Why second one is better? Because it requires less resources. Less resources, shorter paths, and it is faster, right? So that is why very important that to follow proper clock algorithm, clock tree algorithm. That is why we calling it as clock tree algorithm. Is it clear? Very important here. Lot of parameters are there which we need to take care. Right? What will be the distance? What will be the insertion delay? What will be the delay on that path? Even clock will get delayed or not. It is very important that your clock must reach on time. For that you should have shorter path. Right? With less resources. If you use directly connect point to point, what will happen? Resources demand will increase or not? We don't have much resources. Okay. So the main purpose here is to supply the clock to all sequential cells to minimize what? Insertion delay, timing, and power. Why power? How it will affect power? How it will affect power, anyone? Clock is what? Continuously switching, right? Continuously switching or not? For each time period, it is what? Continuously switching. 10 10 10 10, it is switching. So if continuously switching means always active, you check your phones, you just touch your screen, your clock frequency will increase. You play the game, clock frequency, clock, more requirement of clock, faster clocks, right? That is why power is also draining while playing game, not while using touch screen. Why? Less clock frequency is required. That much amount of clock frequency is not required. That is the reason clock frequency is very important here. It also affects what? Power. Because what? It is alpha FCL VDD square, right? So switching factor, very important. Switching factor from 1 to 0, right? What is the switching factor here? What is the frequency? Whether it is 5 gigahertz, whether it is 1 gigahertz, right? Or it is 500 megahertz. Less frequency, less switching. More frequency, higher switching, right? And more power consumption, more power dissipation. So this type of power is called as dynamic power or switching power. Is it visible? Huh? Switching power. This type of power is called as switching power. In your chip, 80% of dominance is because of switching power. Okay, 75 to 80% we'll say. Rest of the 15% is short circuit power. 5%, 5 to 10% is because of leakage power. So this is also very important to understand how we are going to manage power. If you touch data signal, if you touch clock signal, it will affect your power as well as timing. Very important. So that also we are going to learn in advanced session. ASIC design flow routing, right? After everything, we have placed macros, memories, bigger blocks. We have routed power. We have placed all remaining standard cells, smaller cells, right? We have routed clock to all sequential cells. Now what is pending? Everything is done. Signal routing, right? Clock done, power done,
Only last thing is remaining. What is that? Signal routing. So if you see any sequential cell device, right? So let's say D flip flop. How many pins it has? D, Q, clock. Right? Basic pins, right? Apart from this, we have asynchronous pins also, reset and preset. Okay, but we'll talk power pins. PG pins are also there. Right? Total nine pins are there. This is clock, D and Q. Now, what will happen here? Clock is already routed. Routed means what? It is physically connected. Means the metal wire which is getting connected to this clock is having some amount of width. Okay, it is falling spacing also. If one more layer is there, what will be the spacing between two metal layers? So this clock is already routed in which stage? CTS, clock tree structure, clock tree synthesis, right? Now the remaining nets which needs to get routed is what? Signal nets. These are nothing but what? Signal nets or not? Signal nets. Is it routed? Not yet. So this will be routed in last stage. That is called as routing. This is what? Clock nets. This will be routed in CTS stage. What is this? Power. This is ground. So PG is routed when? During floor plan stage in power planning. Like that, your devices will have proper physical connection. Just having a connection is not important. With proper algorithm, with proper strategy, with meeting our PPA constraint, performance, power, and area. These should be met. Apart from that, we have a lot of other electrical issues also. Like there is one case we have noise, we have crosstalk. Now, what will happen? Some critical issues I will tell you here. Let's say there are some cells. Now this is, there are many pins which are connected. These are macros, let's say. So there are buses. So there these pins are connected like this to this macro. Now what will happen if these long length layers are connected like this, flowing like this? So possibility is that, let's say this is we'll take M7, M7. These all are M7. So what is the possibility? And this length is like 250 microns, 150 microns, and this is 100 microns. Now this length is what? 250 microns. What will happen? The possibility of having a crosstalk will be high or not? Yes, it will have more crosstalk. What is crosstalk? Crosstalk is nothing but creation of cross coupling capacitance if two charged metal layers are flowing parallel to each other for longer distance. If there is a longer distance means what? The effective area will increase or not? The effective area will increase. See, when we say layer, so here layers are not, the wires are not circular. You know wires in electronics, you might have seen circular gauge wires, right? But here we are having rectangular cross sectional wire. That is why we are calling it as layers, not wires, right? So these are called as layers. Now if you have layers in such a way where you have area, this is width, this is length. Now what will happen? What is capacitance? Epsilon or A by D or not? This is distance, right? What happens if your area is increasing? Your effective area is increasing or not? The effective overlapping area is increasing. So your cross coupling capacitance, which is the imaginary cross coupling, the behavioral cross coupling capacitance will also increase. This type of capacitance is called as crosstalk capacitance. Okay. So now though we have this long length, right? Long length means what? This length. A is nothing but WL, W cross L, right? Now this will increase or not? This capacitance will increase or not? Right? 250 microns is very huge. This capacitance will increase. So due to this crosstalk and noise will also increase, what will happen? Delay might increase, right? Delay might increase. So how to overcome this? So there are many ways, many fixes. One of the fixes is that you can increase the distance between these wire. This D is there, right? Distance between these two layers. You can increase. Instead of having this much of spacing, let's say this is having spacing X. Instead of having X spacing, you can have 2X of spacing. Twice of X means what? Double the spacing. Instead of connecting the layers on this track, what we can do? Instead of connecting here, what we can do, what possible things we can do is leave this track, take another track, and then connect. If you route like this, what will happen? Now distance is 2x or not? Is it clear? If this is getting 2x twice, now what will happen? Capacitance will also get half, right? It will also get half than before, half than C naught. So your C naught will be less than C1 by what? Half. So this is how crosstalk is reduced, delay is reduced. That is how timing is met. So many issues are there, many critical issues which you have to fix manually. Very interesting. Is it clear? This is just one, I am saying, an example I have shown. So very important stage, routing. Okay. Plus, what happens if congestion is high? Suppose in one area you are placing many cells. Here only you are placing many cells. Right. Each cell is having what? 50 pins, 50 to 100 pins. What will happen? What will happen in this case? Each cell is having 50 to 100. More number of routes will come here or not? More routes will come here. More routing will happen here or not? Whether tracks are available, whether space is there to route all those, maybe, maybe not. But possibility of not is higher than yes. Right? Why? Because of more cell in one place. So congestion is there, right? Less routing track is there. In that case, what will happen? Even though we try to, let's say, forcefully will route it, chances of what will happen? Chances of shorts, right? Chances of shorts will be there. Suppose you are connecting, these two cells are talking with each other. One more cell is there. These two cells are also talking. How you will connect this? Either you connect like this or you go like this and connect. There are two possible ways. Best way is what? Best shortest way is you can go like this and you can connect. This is a possible way. But if you see here, this is occupied or not. You cannot choose on top of this, right? You have to choose another track like this. But let's say all these tracks are also occupied, already used, already routed. Whether it can go through like this? No, already one layer is there, right? So either you have to go like this and connect, or you have to connect like this, right? But it will increase what? Delay. What is the cost? Delay. You can route without shorts, but delay. But if you go through like this, let's say like this, somehow you have connected like this, what you will see? Possibility of shorts. Is it clear? So very important stage, routing. Each and every stage is important here, right? So once your routing is completed, then comes sign of stages. you have to do some checks, like you have done checks after RTL coding, right? Verification. Similarly, we'll have some verification after physical implementation. What are those checks? One first check is what? Physical verification check. That comes under sign off, right? What is physical verification check? After routing completes, you have to check physical verification with respect to DRC rules, LVS and LEC. What is LEC? Logical equivalence check. Means once it is designed, physically designed, whether what is designed after physical implementation, is it same as your golden netlist? Golden netlist, what was the golden netlist? The netlist which we got after synthesis. Whether it is same, functionally same or different. If functionally not same, if it is different, then your LEC will fail. We cannot give this chip to design to fabrication. Good. So if your DRC is correct or not, if DRC rule is passing or not. What is DRC rule? The rules which is provided by foundry, right? Spacing rule, minimum width rule. If it is not satisfying, it means DRC fails. You cannot send your chip to foundry, right? So this is physical verification check. Next is timing check. Suppose you have a constraint of performance to develop a design in 4 gigahertz frequency. But with 4 gigahertz frequency, you're seeing that lot of timing paths are getting violated, not meeting. Your data is not coming in right time. It is not meeting timing requirements. In that case, what we should do? What we should say? Our timing is getting failed. Whether we can send it to fabrication? Answer is yes and no. It depends on what timing is failing. If setup is failing, there are chances that we can send it. If hold is failing, there is very less chance that we send it to fabrication. If setup is failing, that also it should be under limit. It should not fail with big number. Okay. IR drop means related to power. If you have more and more IR drop, means what? Voltage drop in your design. Like I've given one example, right? In that case, what will happen? It will require more power dissipation, means it's no more low power now. So power dissipation is very high. Should we fabricate those kind of chips? If it comes to market, that is the reason some chips which are 10,000, 15,000 phone, why it is less cost? Because they are exporting some chips design to fabrication lab with some defect, not defect, less feature, not less feature, less constraint, less optimization. Yes. So power optimization is less there, means it is already having higher drop. Since we are saying that okay, it is under limit, not that much bad, we'll still send it to fab. So they'll fabricate and it will be mounted in your mobile phones, and that is the reason in those chips you see more power draining and more heating issues, right? In flagship phones, if you go like Elite Snapdragon 8, Elite Gen 3, Gen 6, Gen 8, you will not see all these issues. Gen 3 is latest. Now you will see more latest, which is going to come in next, what we say, quarter. So you will see that you will find that that is why it is flagship. That is why it is 1 lakh rupees phone. Why? Because no matter how much you play games, you operate multitasking, it is capable to handle all those. It will not lag even in those scenarios. That is why it is called as flagship phones, right? Because while doing sign off of power and timing and these things, those are perfect condition. Not perfect, but close to perfect. Okay, so this is the sign off, 3 sign offs: timing, power and physical checks. If this is okay, then we will send it to fabrication lab. So these are tools which I have already told, which is used for different purposes, right? From synopsis, custom compiler, or ICDs, it is also called. Synthesis design compiler, placement, CTS and routing is done in ICC2. SPEF extraction, RC extraction is done in star RC. Timing analysis is done in STA prime time, STA timing analysis. Physical verification, we have ICV, and caliber is also for physical verification. Power sign off from Synopsys, it is called as prime power, but in industry, Red Hawk tools are used. But Red Hawk tools are very costly, so in no institute you will find Red Hawk tools. Okay. So this is what? This is complete advanced physical design flow, starting from sanity checks, floor planning, power planning, CTS routing, replacement, routing, sign off. So this is complete ASIC flow, including physical design flow. Any questions here? Technical questions? Okay. So just I have given you brief about physical design, complete ASIC flow, what is happening in VLSI, how market works, what are all products, what is the end product, what will be your role, what you are working on, what kind of challenges we can see while designing, how much complex is design with respect to technology. All these things I have explained in this session, right? Apart from these are all technical things, I will also give you some non-tech inputs also, right? So let me open one slide. So if you have any questions, you can post in chat box also. So I'll open for questioning here. Yeah. So this is all about technical thing. Now many will have these kind of questions like, what are the opportunities after this course? What are all opportunities after this course? So there are many opportunities, let me tell you. So there are many opportunities in service based companies, product based companies. Okay. So there are basically two types of companies. One is service based companies, one is product based companies. Service companies are those companies which provide services to product companies, right? Service based companies like what? um, Infosys, TCS, Wipro, Insemi, Mirafra. So there are many service based companies, right? So they are providing what? Services to product companies. What services? VLSI design services. Means they will have employees, resources, they'll be sending them to product companies to work on designs of product. Means, so let's say for example Intel is there. Intel is designing some chip on 2.5 nanometer or 1.5 nanometer. They require some people, they require some designers, engineers. They don't have sufficient amount of engineers in their company itself. What they will do? They will outsource, means they will tell to these companies that we want some resources, we want some engineers because we don't have sufficient amount of resources. They'll ask them for resources. So these people will be going here for work in Intel. So they'll be working on same chip with the people who are already working on Intel. So you'll be working here on this chip on Intel, right? So how payment will happen? So payment Intel will give to your service company, and service company will give payment to your company. This is how system works. The service and product. If you directly go to product companies, then the product company will be paying you directly. In that case, the only difference is the payment. Apart from that, the design, the work, the technology, that is no same. That is not different. You will be working in same designs. Okay. So compared to service company, product companies pays higher. But thing is, product companies do not hire many people. Even though they hire from the tier 1 colleges like IITs, mostly IITs. Right? In some cases, we have seen NITs also. So mostly tier 1 colleges they'll pick. More opportunities, where you will see more available opportunities, if you ask me, it is service based companies, right? You will not see lot of openings in product companies. but you will see lot of openings in service based companies. Okay, so this is what about companies, how much you are getting, how much you will be paid after this course. If you are a fresher, if you have no experience with a fresher, just pass out and you join this course. And if you are a BTech person with EC, electrical, right? See, what are all eligible branches? ECE, ETC, telecommunication, all electronic sub branches, all electronics. Okay, and all electrical sub branches. But computer science, IT, mechanical engineers, they are not eligible. If you are from these branches, then you should not opt for physical design or VLSI. Because what I have explained in this session, you might have known that lot of things are what electronic dependent or electronic basics dependent. How these people will cope up. So it's not possible. So these people are not eligible to apply in these companies. Okay. So this is the eligibility as per a branch. Now the about a paid, what will be the payment? If you are a fresher, a BTech graduate with these branches, so you will be starting from around 4 to 5 LPA as a fresher. Provided that you will have internal training from that company also. Depends company to company. Some company will give you some 6 months of training, like internship kind of, or training, or maybe 1 year also. After that training, they will send you to client or product companies for work, for designing. That is how things will work. This is for starting. Once you go into client, you have completed your training process. This will again update and increase according company to company. But this is how you will start as a fresher. Any questions? Any query related to course, technical, non-technical, online, offline? Exhausted? In colleges, you might have 40 minutes session lecturer, 40 minutes, 45 minutes. So every session will be at least 3 hours here. At least theory session, lab session sometimes it goes 1.5 hour, 2 hours also. But theory session will be in on weekend, Saturday, Sunday. So at least 3 hours. Okay. Timing I will update. So this is PD basics timing, right? Which will be on weekdays. So you will have labs. Labs if you are in advance. For theory basics, you will have daily sessions, 2 to 3 hours daily. Digital, CMOS, and physical design basics, and some other topics. Right. Next is PD advance, 4 months. 3 to 4 months will be there. Here, weekdays you will have labs. On weekends you will have theory sessions. Timings will be the period will be 3 hours. What will be the timing, whether it is morning session or afternoon session? It depends batch to batch. What is batch demand, requirement, and availability of that slot? That is how timing is decided. If already all classrooms are occupied in morning slot, then even though you request for the morning slot, you won't get. If there is a means slot is there, then you will be getting that. If you request, if majority of you request. So there are only 2 slots, one is morning and one is afternoon slot. That's all. Weekend mostly you won't have the preference, but weekdays lab session you will have the preference of choosing the slot also. Okay. So all this, whatever requirement is there, right? Whatever you need from institute, it will be provided. You need something notes, it will be given to you. During the course, suppose you are in advanced session and you forgot digital concept and you are weak in digital concept, you forgot something. You want some revision session on digital concept, that will also be given to you based on request. right? Suppose you are not good in CMOS and you forget few things, you want some revision session also, right, during advanced session. So that will also be given. If you want doubt clearing session, I want doubt clearing session on this topic, so that will also be given on dedicated day, and dedicated mentor will be given to you, so that that person can clear your doubts. So whatever you require, any help, any need from institute, that will be given to you. Notes, okay. One more thing is there. Each and every session will be recorded. Okay. All these sessions will be recorded. Every class, lab, theoretical class will be recorded. Suppose for genuine reason, if you have missed some classes, so you can watch in evening, night. What will be the access period of those recording? It will be complete 6 to 7 months in your course period. Complete course period, that all access will be available. Tool access plus your recording sessions access. So everything will be. So you can watch n number of times same session. Okay. If you are Neha, if you are in PD advance, right? So during PD advance, we'll have lab session also. Throughout the week, means Monday to Friday, you will have lab sessions. Saturday and Sunday, you will have theory sessions. If you are a regular batch, if you are a weekend batch, then only weekends are available, right? Morning will be theory session, evening or afternoon will be your lab session. If you are a working batch or e-learning batch or a, what we say, weekend batch. Which profile have more openings, Vidisha? So which profile means, see, this is a physical domain, physical design, right? So I assume that you are asking about front end and back end, right? So front end, we have design verification, DFT. There are back end, some other back end courses like custom layout design also, right? Analog design and custom layout design. Those have very less openings. Design verification has many openings, same as physical design only. But only thing difference is design verification is more of programming and coding based. You have to be very good in programming. But when you come to physical design, here programming is that much not important. What is important? Conceptual knowledge, subject knowledge. You should be not owing only one subject. You should be good at digital, CMOS, some network theory, some signal and system also. You should have some knowledge. So the vastness of knowledge base should be there. So based upon that interest, you should be choosing the domain. I have told DV, PD both have almost equivalent opportunities compared to DFT and custom layout design, which has very less opportunities. Regularly, they don't have openings, right? Out of the difficulty level and challenges level, DFT is comparatively less difficult and less challenging compared to other domains. You will have more work-life balance in those domains, DFTs. Less pay also. If you're getting work-life balance, then definitely you'll get less pay also, right? So it is like some formula. Is job support available only for jobs in India or any other country for master student? So this I am not sure, but I think there are opportunities offshore also. Those are called as offshore placement. Once you can check with the institute manager about this caution. No holidays. So holidays usually given on Fridays, Krishna. But I'm not sure, you can check. I'm not available on weekdays. I usually come on weekends only. So if you ask about me, I take only theory sessions since I'm not available on weekdays. So on PD advance on weekends, we will be having full day classes, right? Full day means morning session will be for theory, like 9 to 12 or 12:30 there will be theory session. 1 hour break will be given for lunch, and after that lunch you will have lab session. So mostly 4:30 your session will be over. So yes, Shreyas, mostly it is full day time. night time will be yours. You can utilize whatever you want to do, night or evening. Yes, any other questions? Any other query? Weekend class will finish later as it's getting less lab time. No, it's not like that. It will complete on time only. Usually weekdays lab sessions are not 3 hours. It will be around 1.5 hours to 2 hours or sometimes 2 hours. Depends on how students respond. Right. So somewhat it may extend for weekend batch because of course compared to weekdays you will have comparatively less. But if you see the 3 plus 3, some lab sessions will go like 4 hours in weekends. So you can expect like it can go to 5 p.m. also, 5 to 6 p.m. So it depends on how we get responses from the audience. If they're fast in grasping and understanding means that batch will go faster. If people are struggling with some basics, not understanding means that batch will be slower. It's simple thing. Will tools be accessible whenever we need? Yes, it is 24/7 accessible, right? You can access. So two things which I haven't told, I will mention here. So tools, EDA tools access licenses is 24/7 available, right? And recording sessions. Recorded sessions are also 24/7 available, right? But what till what span? What is this? Till what span? Till your course ends, right? So approximately you can say 6 to 7 months, right? 6 to 7 months. No, not 6 to 7 months. See, recorded session will be for 6 to 7 months. Tools you will get from PD advanced sessions. Tool access you will get from PD advanced, not from PD basics. What you will do from PD basics if you do not know anything on advanced. So this access you will get from PD advanced session. So mostly this access will be there for 4 months. What if I want advanced PD in parallel with PD basics? What are the timings? Parallel means, see, there is a sequence. If you do not know PD basics, I mean the digital and CMOS, how we can expect PD advance from you? Understood what I'm telling? So very important that first we complete PD, I mean digital and CMOS. Then we, if you are good at PD, I mean digital and CMOS, if you are confident, you can directly start from PD advanced session. If you think you want some revision, you want some clarity on basics, then you can go with basic sessions also. But parallel, I don't think it is not correct also. We cannot follow that sequence. Yes, any other questions? Okay, we will stop here. I hope you like this session and I hope we will continue and we'll see in regular sessions, in advanced session again after PD sessions. Okay, thank you everyone. If you have any other queries also, so in ground floor we have office. You can ask any queries related to fees and if you want to pay in installment or some other things that is also available. You can check with them. The all non-technical things, right? So recorded lecture have any watching time limit? Can I watch same lecture multiple times? Yes, yes, Vidisha. So there will be some watching limit, but on request this can be updated, right? So there is no limit technically, if I say, right? There will be no limit. You can watch n number of times, n number of times can be watched.
Yes, you can. Thank you, everyone.